Welcome back to another lesson. Having finished the optimization process, we can export a video to visualize the results. So, on a new cell, we begin by importing CV2, an open source computer vision library that is used for image and video manipulation. This is essential for the creation of the video. This library has many useful commands. However, we are going to make use of the cv2.videowriter command, which allows us to write our NumPy array into a video. It takes the following 4 arguments. The first argument is the name of the video file, essentially what you want the name of the video to be. Let's define this as output.mp4, as we want an MP4 video of our output. The next argument is a bit more complex as it refers to the specific video codec that you want to use. Video codecs simply refer to different compression and decompression algorithms, and there are many to choose from. Some are more versatile than others, and each codec has something unique to offer. We are going to use the xvid codec, which can be input using a useful built-in CV2 function calling the cv2.videowriter_FOURCC function. You can simply input the codec you want to use, and we will use the xvid codec. And we put an asterisk simply to define a variable number of arguments. We will use the xvid codec. However, for a list of other available codecs, the documentation for this fork function can be found online. The next argument that our video writer function takes is simply the desired frame rate of the output video. As we have an array consisting of 300 images to work with, this frames per second argument is going to determine the length of our video. I typically export a video that is 30 frames per second, which is pretty standard. This means that with 300 images, our video will be a total of 10 seconds long, which is reasonable. You guys can feel free to play around with this parameter as desired, it's up to you. And finally, our last argument is going to come in a form of a tuple that contains the output width and height of our video. This can simply be specified as frame width and frame height. However, we have yet to define these values, so let's go to a line earlier and extract our target image shape. We call the image convert function to our target image, and we use the shape method to get the dimensions of our target image, and we can store the shape values into frame_height and frame_width, equaling the following. And finally, the last argument is simply the image depth. We won't be needing the depth, so we can place an arbitrary holder variable right here. And that concludes the arguments that our video writer function requires. Make sure you've copied everything down correctly. We have specified all the required parameters of our output video. And now by calling the cv2.videowriter command, we are now able to add frames to our video. Let's store this call into a variable that I will simply refer to as vid. In the future, we will call vid when we want to interact with this video writer call. And now, as we have an array containing 300 images to add to our video, let's run a for loop. For that will range from our variable I from 0 to 300. In the range, for I in a range that goes from 0 to 300, with each iteration of this loop, we will add a frame to our video. This can be done using a simple vid.write with the image frame that we want to write into our video. Now, before we can run this loop, our frames need to be processed to ensure that the video output is proper. The first thing we need to do is to access our image array in the ith index, image array, in the ith index that's currently being iterated through, and to store this value inside of an img image variable. Alright, the same variable that we will write to our video with. The next step is to remove the normalization of this image. Currently, all the pixel values range from 0 to 1. However, we want our values to range from 0 to 255, as regular RGB images would. This can be done by taking our image variable and multiplying each pixel value by 255. This can be restored inside the same image variable. Alright. And now before using the vid.write command, we also need to convert this image into a NumPy array that has an 8-bit integer data type. and that is the only data type that the vid.write command accepts. This is a limitation of the CV2 library. However, it is something we can get easily around. So setting our image variable equal to numpy.array, we can return an array that is the same as our image, however, is going to have a data type equal to numpy.uint8, referring to an 8-bit integer. Fixing up the spacing. All right, we should be good. Note that doing this before removing the normalization will not work, as converting values between 0 and 1 into this will round them to the nearest whole number, which will result in a lot of lost data, so make sure that you follow the respective order in which these lines were placed. Alright, now multiplying by 255 and then converting to ints ensures that the relative differences between pixels are maintained, and our image data is preserved. Finally, just one more step before we are ready to utilize the vid.write function is we need to ensure that our image is in the RGB color space. OpenCV tends to treat images as BGR, which is the reverse of RGB. And for this reason, we need to specify the RGB color space. We can do this by setting cv2.cvtcolor for convert color to convert the color space function, and we feed our image as an argument. And we specify that we want to convert from BGR to RGB. cv2.color BGR to RGB. Intuitive enough. Our image frame is finally ready to be written to the video frame, so we can allow this for loop to run over 300 iterations to ensure that all 300 frames are written to our video. And when this loop is done, we simply want to conclude with vid.release. Beyond the scope, vid.release. This simply closes the video writer that we opened earlier. It informs our code that the video is fully written and is ready to be saved. In order to verify this, it seems that my runtime disconnected, so what I'm going to do is rerun all of my cells, and I'll see you in a bit. Alright, and now having run all of our cells on a new cell, we can print our collab workspace to see if our output video is present, and we do this with the ls command. And we can see all the files in our Google Colab workspace. You can see the images we uploaded alongside a video file titled output.mp4, the exact name that we specified. This file can now be downloaded and viewed for your personal satisfaction. It will also give you an insightful look into how the optimization process of the target image takes place. And so downloading this file is pretty simple. You can open a new cell from google.colab. You can import files. This library helps you deal with files on the Colab notebook, and now we can simply use files.download and specify the name of our file, output.mp4, to download our file when this cell is run. Alright, so I'm just going to run this cell and wait for the download to finish. It has finished quite quickly. Let me just fix this. Open up the video. Alright, and playing this video from the optimization process we just ran, we can see the style of our image slowly leaking into the contents of the target image. And it's very fascinating to visualize. I think with even more iterations, this would become increasingly interesting to watch. So feel free to experiment with this code. And before we conclude this, I've actually left you a lot of content and style images in the previous article, which you can feel free to train with our current code. This is just one of our co-instructors who we blended with this image, and it blended pretty well. So feel free to test the following images for further visualization. It's completely up to you, or use your own images. Alright guys, that concludes the toughest section of our course, style transfer. I hope you enjoyed the course and have a lot to take away from it. PyTorch is a very powerful library, and as this course demonstrates, it is capable of a variety of fascinating applications. I have really enjoyed being your instructor for the course. See you guys!